So, hello and welcome again. Welcome to another Saturday live stream, microscopy live stream. Today I would like to talk about oil immersion microscopy. I'd like to show you a little bit oil immersion, how oil immersion microscopy works. I have prepared some specimens here, but I would like to do the following first. I'd first like to talk a little bit about some theory for maybe about 20 minutes, simply to explain you the background a little bit, and then we can put a few things under the microscope using oil immersion. Okay, so first of all, you see my desk over here. I have prepared a lot of things already, but I would like to show you first what oil immersion microscopy is and which objectives you need. And of course, if you want to ask any questions, then please post them in the chat. I see that people are now already joining in here and saying hello from all over the world. I personally like this a lot. It's a very worldwide background and very international. So what I have is the following here. I've brought along, simply because it's easier for me to demonstrate, an oil immersion objective. And there are a couple of important things that I would like to say here. Okay, I'm just going to remove this here. This is an Olympus from my first microscope that I had. It's a nice objective, and when you look at it, then you're going to see that it's 100 times the magnification objective, and there's the word oil written on top on here. Okay. And that is very important. You can only use oil immersion microscopy using an oil immersion objective. And if you don't use the right objective, you might actually end up damaging the objective. And for those of you who are completely new to oil immersion microscopy, it works like this. I've got a slide over here. I'm going to take any slide. I'm just going to use this slide over here. In oil immersion microscopy, you put a drop of immersion oil, I've got some here, directly on the slide. And then you rotate the objective into the oil. So this means that the front part of the objective will be covered in oil. So there is no air between the slide and between the objective. Okay, and this increases the resolution. Okay, because the air has a different refractive index than the oil, and for this reason, if there is oil between the front lens of the objective and the slide, then you have a better resolution. The image is also brighter. However, you can only use this technique with oil immersion objectives, and actually in most cases this is always the 100 times magnifying objective. I mean, there are some companies that basically also offer other magnifications with oil immersion, but generally I would say it's the 100 times. Now a little bit some background, consider my own opinion about this. I personally am not a fan. I'm not a fan of oil immersion microscopy. Because but I'm using it, but I don't like using it so much. The reason is because it's a little bit stressful. Okay, because you have got oil around, and then if you then accidentally, if you're a little bit mindless, and then if you switch in and rotate, and you have then another objective contaminated with oil, that actually might damage the objective. So generally, what I recommend is that instead of getting 100, actually some of you or many of you will already have 100 times oil immersion objective because it came with your microscope. But generally, I would say that exchanging it with a 60 times dry objective, these are the regular objectives are called dry objectives, I would say generally has a wider use, because you don't have to use immersion oil, and because once you've got oil on the slide, you cannot switch back to the lower magnifications, because there's simply too much of a risk of contaminating the objectives and then damaging them. Okay, so this means we have to be a little bit careful here, and it's a slightly more advanced technique. Some background story, a little bit. I wanted to tell you something that simply so that you understand the context a little bit better. I'm a teacher in school, so of course we also teach, as a biology teacher, teach microscopy, and many of the objectives used to be quite dirty. Because students accidentally used the non-oil immersion objectives, the dry objectives, with immersion oil. So it got all covered, and then we had to clean it, but there was still, some oil left on here. And so this basically means there is some reduced usability then of the objectives, because then the students raise their hands and say, well, I cannot see anything, everything is so blurry. And then I look through it, of course everything is blurry, because the 40 times objective, the non-oil objective, is all oily, right? This is, and when I phoned the sales representative of Olympus a few years ago, and I had a nice little chat with him, and I told it to him, and says, yeah, the problem with students and oil immersion, we have to be so careful, because then students will use immersion oil and contaminate and damage the regular objectives. And then he started to laugh, the sales representative, and says, yeah, it's not only students that are beginners that are having this problem. We're currently repairing an objective where a laboratory worker accidentally used immersion oil on a non-immersion oil objective. And he said they had to completely disassemble the objective, because somehow the immersion oil went into, you see this is there, there's the gaps in here, right? Somehow went into the lens and behind the objective, behind the lens. So they had to completely disassemble it and clean everything. And if you consider that some of those research objectives actually cost several €1,000 or several $1,000, well, then you can imagine that it's actually needed to be repaired, okay? So there are a couple of comments again. Some companies do make 40 times oil objectives. I was able to find 10 times oil. Wow, I've not seen that before. And 20 times oil objectives on eBay. They work great, but the cleanup is a pain. Yeah, when I bought my 60 times objective, I was asked by the company, which version do you want to have? Do you want to have the dry version, or do you want to have the oil version? So that is basically the thing. So we have to be a little bit careful here. So when you use oil, then you basically got to be careful that you don't use the lower magnification. So that's one thing. And the second thing is the following. Look, I've got a whole bunch of permanent slides here. Okay, you might have already seen them before if you joined my show last week. These are permanent slides, and those permanent slides, of course, have the specimen mounted in mounting medium. There's a label here, and you cannot use oil on those slides, or you should not use oil. The reason being is because the oil is going to mess up everything. The oil is going to go on the label, then maybe the glue is going to come off. It's very difficult to clean it again. Very difficult to clean it again. So I'm just saying there are some limited uses to oil immersion, but sometimes there is no way around. Okay, so for some of my videos that I made, I had to use the 100 times oil immersion, because otherwise I would not have been able to see it that well. Okay, so that's number one. Okay, so remember the correct objectives. Okay, so number two. Let's have a look a little bit at the immersion oil itself. I have got here a few bottles here. Look what I've got here. Look at those here. I don't know if you're able to see this so well. Yeah, but they you can look a little bit yellowish, right? This immersion oil looks a little bit yellowish. And then I have two bottles over here that look, completely clear, white. Okay, so the oil is white, and there's oil that's yellowish. Now, there are two types of immersion oil. The clear ones, these are the synthetic immersion oils. And then there are apparently what they call natural immersion oils, and they have a yellowish color. So those three bottles, they came with some of the microscopes, the low-cost microscopes that I ordered, that I got. So these are kind of also some no-name microscopes. When they have 100 times oil objective, they come with a bottle like this. It's a little bit yellowish. And then these here are from the company Olympus. And that is the one that I'm using right now. And this one here, this bottle over here, is almost 25 years old. This was from my previous microscope. And it's still good. Okay. You're going to say, of course, why should it not be good? Because I would like to show you now a little video that I made, a short video clip of what happens if the oil turns to old, the natural one, if the natural oil turns to old. I'm just going to show this to you. Where So I'm going to quickly show it to you. So I'm opening a very old bottle, okay? And look what happens. You see this yellow thing here? Yeah, that is the solidified immersion oil. It has turned completely hard because there are certain solvents in the oil that have evaporated, and this immersion oil has never been used. Okay, so this was actually one of the bottles in school that, this is actually tells us that we have to, especially when using natural immersion oils, we have to clean it off. Otherwise, there is the danger, of course, that the oil to turn solid. Okay, but this does not happen with the synthetic immersion oils. Just so that you're aware of. Okay, a few more comments. If you dare triglycerin immersion lenses, you will consider oil cleanup a piece of cake. Water immersion actually is not too bad. I've read somewhere that there is indeed a company which makes lenses which work both for oil immersion and water immersion. Water immersion is when you have, as it says, is when you basically take the lens, okay, the objective, and instead of putting it into a drop of oil, you put it into a drop of water, okay. Apparently the refractive index is very similar, and it also works. So I've heard of a company that also does this. Yeah, it makes those immersion objectives, so water immersion or for oil immersion. Yeah. About glycerin, I might try that, not on my good microscope. I'm really sensitive about that one, but maybe on the other microscopes that I have, I might actually try also glycerin immersion, because the objectives are not that expensive for those microscopes. Okay, so let's have a look. So I will be using this here. I just wanted to show you also before I actually start preparing some of the specimens. Also wanted to show you what came along with this. Those from the low-cost microscopes, they just came in like this, and this one here from the company Olympus. I don't expect them just to send you a bottle of immersion oil, but along with this bottle comes this here. I cannot believe this. A safety data sheet. Yeah, I mean, when I first saw this, I said, oh my gosh, why that? It's several, it's in different, no, actually it's all in German. It's all one language, okay? On basically, stability, reactivity, health issues, all of these things. It kind of scares you a little bit when you read that. But in reality, when I contacted the company, I asked, is it really that dangerous? It says, no, it's, but there are a couple of chemicals in there, just like with any other substances where you just have to know it. And they simply document everything very well, okay? So I just wanted to show you a little bit that there's some of the companies will really go to great lengths in documenting everything, okay? Yeah, so another one. Zeiss has a series of lenses that makes oil, glycerin, water immersion. Even on eBay, they're very expensive, though very sharp, okay? So this is there are companies that actually do that. So what next? I want to show you also something right now. Just right now at the beginning, so what I'll be doing later on, so that I don't have to show it to you later, okay? So I'm going to switch over to the microscope view, and what you have now over here on the side is you see the focus knob, and there is a lever over here, okay? And I would like to explain this lever. Not all microscopes have this, but some do, and for this reason, because I will be using this lever over here for oil immersion, I just wanted to demonstrate to you what it does so that you understand better of what I'm doing, okay? Because this is actually quite convenient. It's not essential for oil immersion, but it makes life a lot easier, okay? So this is a lock lever. Just want to show you what you can do with that. I don't know, maybe I'm gonna move this a little bit closer here. I don't know how does this work. Okay, let's do it like this. Okay, and I can push the lever forward and backwards. Okay, so that's releasing it and that's locking it. Okay, so you might actually see this. And what it does is when I lock it like this, then I can lower the focus. Yeah, I'm lowering the stage, and then when I go back, it will block there. It will remember the position. Okay, yeah. So what I can do is I can actually, when I've got everything in focus, okay, everything is in focus. I will lock it, okay? I will lower everything, yeah? So I will lower the stage. I will put my drop of oil on the slide, and then I will go up again, and it will simply lock on this position, and it's going to be in focus. So there is no risk for me crashing the objective into the slide, okay? Again, it's not absolutely necessary, but I will be using this lever here, and for this reason I just wanted to demonstrate this, okay? So it's kind of the focus lock lever, it's called, okay? So, but again, many microscopes might not have this, yeah? So, but I will do the following. I will now show you again the stage here on top. Okay, I've got a little camera on here. And I need to focus this again. There is a little lens that I can turn. I think that's better. Okay. Yeah. So what I will be doing now is I will be I've prepared here a small water sample, and over here a yeast suspension, which I would like to, and I need some lighter as well. And I'd like to now make a slide, and this is the thing that I would like to do now. And when you make when you work with high magnification, something that is really really important is that you really make sure that the specimen is very, very thin for several reasons. Okay, the specimen has to be thin because the depth of field is very low, obviously. So this means that if you have some vertical movement of some organisms, then they will immediately go in and out of focus, and it's very difficult to see. Okay, so that's number one. And the second reason why you need a very thin layer of water is because otherwise the cover glass is swimming. Okay, and when it's swimming on the surface, and then when you have oil on top of it, then every time when you focus and when you move the slide, then it's going to kind of drag along the cover glass. Okay, so it's got to be very thin. Okay, so let's do that. So where are my slides? I put my slide box somewhere, and then here they are. Okay, and I'll take a slide. And I mean, there is really nothing special about this. Okay, I will simply use the water sample first. I'm gonna take my pipette. I have to admit, I have not tried this sample. There's some solid stuff floating around. I'm a little bit worried that still it's going to be too thick. And I put a very small drop here. And what I'm going to do now is of course I can use a regular sized cover glass, but I'm just going to use right now a big one. I got myself those huge ones, and the reason why I'm using those is because then I have a large area here where I can do the oil immersion microscopy, and there is not so much of a danger of me when I move it, that basically I will be going off the edge of the cover glass, and because of the large surface area. Basically the slide, the cover glass also sticks quite well to the slide. Okay, but I see again there are some fingerprints on here. Okay, and if you use a very large or fairly large cover glass, then the liquid will also spread larger, and then that means you will get also a very thin film, hopefully a very thin film of the specimen. So let's try this. Still a few fingerprints on here. Goes on top here. Okay, and you see that it, I don't know if you were able to see this, but it immediately spread and made a very thin layer. Okay, so and then I just do regular microscopy, and I work myself upwards with the magnification. Okay, so let's have a look. You should be able to see this here. I put it in here. I'm going to move everything else out of the way first, otherwise we're going to knock over a few things. I don't want that. So, and I have to focus. I don't know. And this is now the 4 times. Ooh, look, I can't go higher. You see, I cannot go higher because of the focus lock. Okay, I have to release it, and now I'm able to go higher. Okay, so this was actually a nice demonstration of. So I've still got all of the filters in here. The light. So, yeah, I don't see any movement. Looks pretty, pretty dead. Yeah, or all of the cells and all of the organisms are kind of squeezed in. Do you see those horizontal stripes? Yeah, these are. Yeah, I didn't clean it properly enough. But it doesn't matter. I'm just trying to demonstrate this here. By the way, I now also have an arrow that I can use for pointing at objects. Okay. So this is now the 10 times. This is now 20 times. Okay. Yeah. I don't see any movement here. Maybe the sample is too old. I wonder what those round things are. It doesn't really matter. I just want to demonstrate. Here's some diatoms. Yeah, could be some diatoms here. Okay. Or anything else here. Let me just find something of interest. I don't know. Otherwise, I'm just going to stay here. Okay. So let's move up. This is now, 40 times. You know what I'm going to put in the D? I see a little bit. I'm going to put in the condenser again because I have to have a little bit more clarity. Okay. So I now switch over to 60 times. Okay. And in case you're new here, some weeks ago I demonstrated this 60 times objective does have a so-called a correction collar. So you can rotate this part here to adjust for the thickness of the cover glass. Okay, so you basically just adjust it until you have the optimum quality. And now I'm going to move over and I'm going to now switch in. This is the 100 times oil immersion objective. Okay, that's the one with the white ring. And now let's have a look at it, how it looks like without immersion oil. Okay, that's now without immersion oil. Okay, the light has to be adjusted as well. And yeah, okay, I'm just going to leave it at this setting. And this is how it looks like without immersion oil. Okay, I'm going to also adjust now the condenser here. There was a little bit of movement. Okay, so you see it's still kind of okay. So, but now I'm going to do the following. I'm going to now add a drop of immersion oil. And I'm going to have a look at it then again. So when adding immersion oil, if you do not have this focus lock lever, what you do is you carefully rotate it away. Okay, you apply a drop of immersion oil and then you rotate it back in. Okay, just for your information, I've got a setting right now where I don't know how do I do this, where it always automatically adjusts the brightness. So that's why. Okay. Yeah, so this is basically the way that you normally would do it. If you don't have this focus lock lever, you kind of carefully rotate it away. You put a drop of immersion oil right in here, yeah, and then back. Or in my case, I have got another 40 times objective, a phase contrast objective over here. But in your microscope, most likely you won't have a large objective blocking the space here. But most likely, again, it's a short 4 times objective. Okay, so there you'll have enough space to add immersion oil. But what I'm going to do now is I'm going to, say that this is now in focus. I'm going to now lock the lever, okay? So I'm going to lock it, okay? So I've locked it now, and look what I can do now. I can now lower it, the stage, and then when I raise it again, I'm using the coarse focus knob now, okay? I raise it again, all the way to the top until it blocks, and I'm back in focus, okay? So that's really nice. Yeah? So this basically means I have a much easier time applying now the immersion oil, and then I simply rotate it up again, yeah, and it's back in focus. Okay. Before I do that, I would like to address some of the comments here. So thanks for the info on the focus lock. That will help a lot. Yes. Some of my oil lenses are just blurry. I try to use them dry. Well, generally, if you use the oil lenses without oil, then they should be blurrier than if you use them with oil. Okay. I'm from India and I'm doing my UG in microbiology and got inspired by your videos. Oh, thank you. I would like to request you to make a video on gram staining. Okay, yeah, gram staining of bacteria. Okay, we'll have to get the stains and then I can show you how to do this. So what I'll do is the following. So let's lower it. Okay, you can of course see here in the corner here, obviously you can see here what I'm doing. And I'm going to now, here is the bottle with immersion oil, and I'm going to now apply a drop of immersion oil directly on the cover glass. Okay, and then I change the focus again. I raise it again until it goes in here. Yeah, and you can actually, and then what some people do is the following, because there might be a little bit of bubble in here. Some people actually go it like this and distribute it. Okay, and I think you might be able to see now that it actually is, I'm going to increase the brightness, yeah, much more clear. Okay. Yeah. Yeah, it is not only brighter, but also more in contrast. Yeah. And I can actually open the condenser a bit, go down with the light, and let's play around a little bit with the prism here. Okay. This seems to be, I mean, this looks green, so this seems to be some kind of algae here. Okay. And then, of course, I can still move around. But every time when I move around, of course, I'm also, of course, creating an oil smear on the cover glass. And if I do this too much, then I might have to reapply some of the immersion oil, because otherwise, the oil film might actually, rip. Yeah, and there might not be. There was the movement over there. Okay. Something that I also sometimes notice is the following: that when you move, then the focus or the, for example, look at this guy over here. Okay, look at this here. Okay, look when I focus. Yeah, do you actually see it move? And the reason why it moves is because of the oil, and so there is a very tiny amount of pressure being applied on the cover glass. Yeah, yeah. So, yeah, you're right about the bubbles. Bubbles can ruin the image. Yeah, so there is. It's possible that sometimes there are bubbles between the in the oil. Okay, and in this case, what you do is you can actually go a little bit like this. Okay, to remove the bubbles. Yeah, but okay. So let me go up a little bit more with the light again. Yeah, I've seen already more interesting specimens, but yeah. So that is basically some diatom shells. But now what? If I go back now using the 60 times, I'm afraid of doing that, because I might indeed dip the 60 time objective into the immersion oil. I don't want to do that. Okay, so this is something where you have to be a little bit careful, because instinctively, if you, like in my case, I like to switch magnifications quite often, and then you don't think, oh my gosh, yeah, I'm actually using oil immersion the whole time. You forget about that, yeah, and then you rotate it, and then it gets contaminated, yeah, yeah. Is it possible to use oil on cover slip? Well, this is what I have done right now. I've now applied, but I'm going to show you now also later a heat fixed slide without a cover slip. Okay. This is also possible. It's actually the process that I've been using in microbiology. In the microbiology lab, I've rarely, I wouldn't say never, but I rarely used a cover glass, because I always used a heat fixed slide and also a gram stain slide, which were heat fixed. I'm going to show you what this is in a minute. Okay. Yeah. So yes, it is possible to use immersion oil on a cover glass, and it is also possible to use immersion oil instead of water as a mounting medium. Why would you do that? Some specimens, I give you an example, like birds' feathers, okay, are very hydrophobic. They're oily, they're fatty. And if you add now some water, and if you want to make sure that there's water around it, it won't work because the water won't, the feathers won't attract the water. And there are a lot of bubbles. So you can use, as a mounting medium, you can use, I've used, for example, regular vegetable oil for cooking oil. Or you can use the more expensive oil immersion oil. But for the oil immersion microscopy, for the oil between the cover glass and the objective, only use dedicated immersion oil. Okay, some more comment here. If I think I will need 100 times oil, I use my set of low power oil lenses I collected over the years. Yep. Also possible. You see, what's important is not really whether it's oil or not alone, but is the resolution. I'm going to switch over, and that is the number, the value here, the numerical aperture. Yeah, so this is 1.30, for example. Yeah, and that is actually the thing that provides the resolution. You will notice that there is a dash over here. Normally, you have 17, the number 17 written here, and 17 means 0.17, my mistake, like over here. And the 0.17 means that the cover glass thickness should be 0.17 millimeters. Now over here in an oil immersion objective, you don't have that because the lens does not, under quotation marks, does not see a cover glass, because the light will be first in water, then in a cover glass, and then in the oil. And so the lens actually does not see the cover glass, so to say. Okay, so for this reason, and also because it's possible to use a slide without a cover glass for oil immersion, as I'm going to show you in a minute. For this reason, there is no cover glass thickness written on many oil immersion objectives. Okay. So, another interesting comment. I clean microscopes for physicians and veterinarians. I have a veterinarian applying immersion oil directly to a dried blood smear. Have you heard of doing that? Yes. And I'm going to show you this. Okay, I've not done it with a dried blood smear, but I've got here a yeast suspension, and I'm going to show you how to heat fix the slide. Okay, this process is called heat fixing, and is actually quite common. I would say it's probably for observing in oil immersion. It's probably more common than actually using a cover glass. The reason is because you get a very thin film. Okay. Text routinely used oil on dry blood smears. Yes. So what I'm going to do now is I'm going to so that's the microscope view again here. Okay. So that's as we've seen, and now what I can do now is I can simply lower everything again. Okay, I can remove the slide. Okay, and I'm not going to clean it yet. Okay, because you might be able to, of course, see that there is a little bit of oil on the cover glass. The cover glass being here pretty big. Yeah. So that's number one that I would like to do. Number two, I'm going to just show you a regular yeast suspension. Okay, so I've got some. Just before I started, I prepared some dry yeast. Put it in here, and I'm going to just make a regular slide, just like I did before. We're just going to have a look at some live yeast cells first. Okay. In case some people have been asking me about this pipette. Okay, oh, here it is. Okay, normally these guys cost hundreds of euros or dollars, but this one was a pretty cheap one. I got it, I think, for around 30 or so. It's not the best quality, but it's good enough for picking up the samples. Again, a very small amount. Okay, I do not want to have a very thick film, and I'm going to use again this here. And it's a little bit annoying, I have to tell you, is the fact that those cover glasses are not entirely clean. They're pretty dirty, actually. You see, if you let the light reflect, there's some smear, even though they're actually fresh out of the box. So what I usually do is I dry wipe them. This is it's a microfiber cloth for cleaning glasses, but you can also use regular tissue paper I found this to be enough. Yeah, it's no need to actually wash it in water or alcohol. At least for my purposes, it's fine. Yeah. So and let's go for it again. So this is now a yeast suspension. Okay. And let's have a look at this again. Microscope view. Let's go all the way down again to the low power. Let's go up. If I can find it. Yeah. Yeah, all of those dots that you see over here, probably yeast cells. Let's go up with the magnification. Okay. So let's go up yet further. So, and here we already start to see them. So, yep. Interesting, there's some other stuff here as well, some contaminants. I don't know what this is. Okay, but you get the idea. And let's open this up a little bit. What? No, this is kind of weird. Here they are. Okay. And 60 times. What you can do is you can also add a little bit of sugar, and after a couple of hours you're actually going to see them divide. You can see them at this typical asymmetric division called the yeast budding, where you have a small bud growing out of the of a yeast cell. Okay. Yeah. So these are basically, what is these air bubbles? I don't know. Yeah, but you get the idea. Okay, so these are basically yeast cells. So volume size pipette is a question. Yep. Why not? Before I forget. Well, this one over here is a. I gotta change this here. It goes all the way up to 1,000 microliters. It's a milliliter, but I'm not using this for measuring out. Okay, I'm just using this for essentially, pulling out samples. Yeah, in case you're kind of wondering, there is if you press this button over here, then you're actually able to throw off the tip, and sometimes the whole thing comes off. That's the quality aspect. Okay, but otherwise it's fine. Yeah. Okay. Yeah. Oh, look at this. Yeah. Yeah, and with this one, you're able actually to pull in. You're able to draw in the liquid. That's why it only cost 1/10 of the price that it normally would cost. Okay, so so these are basically the yeast cells. Let's have a look at it under the microscope again. So this means I'm not under the microscope, under oil immersion. So I'm going to now rotate in the 100 times oil, and probably there is not enough oil on there, so it is now contaminated with oil, the lens. And I think it might not even make proper contact. So what I'm going to do again is I'm going to lock the whole thing using the focus lock. Okay, I'm lowering everything again. Let's apply a little drop of immersion oil. I could see actually there was already a little bit of oil now on it. So actually I got quite a lot now. And let's go up again. Now we're making contact. Yeah, and to remove any possible air bubbles. Yeah, and you're going to see that actually you can actually see now some structures and details inside the cells as well. Yeah. Maybe I'm going to increase the brightness a bit here. And if you look into one of those cells, you can actually see that there is some, you're able to now see that there's something in those cells as well. Okay, and let's readjust here at the top. Yeah. So it is indeed increasing the resolution quite a bit. Don't know what this here is, this round thing here. I don't know. Yeah. Can you go over what the best way is to remove the oil after you're done? Yeah, I'm going to, during the session. Yeah, what I'm gonna, yes, I'll do this at the end. I use a lens tissue paper wherever I put it. Where did I put it? Yeah, I got some lens tissue paper, which I prepared. Honestly, over there. Yeah, I got some. Yeah, it's some dedicated lens paper that I'm going to use to carefully wipe off the oil afterwards. It is not necessary to completely clean it afterwards with alcohol and so on. That's not necessary. And some people who are using this routinely, they only quickly wipe it off and they say it's okay if there's a little bit of oil left on it. I still would clean it because if there's oil left on it, it might actually collect dust. Okay. So for this reason, I do recommend that it's being cleaned, but there's no point in overdoing it and actually using solvents to remove the oil. I think that's a little too much, okay? So, but you get the idea. So here, these are basically now the yeast cells, at maximum magnification, and then the yeast cells here, they are not budding because this was dry yeast, so I'd have to add a little bit of sugar and wait a few hours, and then I actually might see that some yeast cells will start to form tiny outgrowths where the cell is dividing, because yeast is dividing asymmetrically. Still regular mitosis. Concerning the DNA, of course the two cells are genetically identical, however the cytoplasm is divided asymmetrically, and that's something that you cannot see here because I use dry yeast, so I have to add a little bit of sugar and wait a little bit, and then you're able to see this as well. Okay, so this is basically another thing, and I would like to show you now a little bit some heat fixing, how this actually works. Okay, because this is actually the standard way that you use for preparing bacteria, and let's also say, I don't know, I guess also yeast. So I'm going over here again to the desk, and what I've done here is I've applied a yeast suspension on the slide, and I allowed it to air dry. That's it. No heat applied, no nothing. Okay. You simply have to wait, I don't know, depending on how much you've got, you have to wait until all of the water evaporates, and then now you have a very thin layer of cells on here on the slide. And by heat fixing it, I would pull the slide now through a gas Bunsen burner about 2 times, okay, with the specimen pointing away from the flame. How hot should it become? It should become so hot that you're just barely able to hold it without. So it's got to be hot, but it should not burn you. Okay, so that's the test, so to say. So when I've been doing this, I knew exactly already how fast I had to pull it through the flame 2 times, and then I always got it right. And then you could place it here. It was very hot, but it didn't hurt you. Okay. So this is number 1, and then what I'm going to do is by heating it, I'm going to be using a lighter, okay, because I don't have a gas Bunsen burner. And by heating it, what happens is that the cells, of course, they die, but they're baked to the glass slide, just like an egg, for example, is baked to a frying pan and sticks, because somehow the proteins, they cross-link with the glass. And this is important because otherwise, if you want to stain it, then the stain would otherwise flush the cells away. And we don't want that. And for this reason, you heat fix it to bake the cells to the glass slide so that you can actually do staining. For example, there's been a request for me to show how to do gram staining for bacteria. You have to change the stains several times, but you do not want the cells to be washed off. And for this reason, you need to bake them to the slide. And when I use, I'm not going to stain them right now, but when I use oil immersion, I don't think that the immersion oil is going to remove them, but you just want to make sure. I just want to make sure that they're baked to the slide so that also the immersion oil does not kind of wash them off. Okay, that's kind of the idea here. Okay, so there have been a few more comments. Okay, thank you for your videos from Nova Scotia and Canada. Thank you. I'd recommend cleaning off all oil with an appropriate solvent if you're going to store the lens for long term. Yes, If you store the objective lens for long term, it is important that you really clean off the oil for two reasons. Number one, it's going to collect dust otherwise. And number two, remember those oils that I showed you before, the yellow ones, they solidify over time, okay? And you really want to make sure that if you use those natural immersion oils, that you really have them removed. Otherwise, they are going to turn hard on your lens, and you don't want that. I should have known someone would ask. I use a solvent designed for cleaning paraffin. Honestly, I don't know what the proper solvent really is. One guy told me to use gasoline. Oh, be careful, folks. Be careful. For cleaning, if you want to clean, the lenses, then be careful because look over here. This here is an oil immersion lens. Do you see the white ring here? I don't know if you're able to see this. This seems to be some kind of cement, plastic, or rubber maybe. And has been applied here to seal it off so that no oil can go in. And now if you use an improper solvent, you might actually damage these things, or sometimes there is a so-called, the lenses are also glued in place. So what you generally want to do is you want to prevent any liquid flowing into the lens, of course not the oil, and of course not any cleaning solvent. And the solvent that you use should be very volatile. And generally you go with that what the manufacturer recommends, or one of the things that has been recommended also is a 70% ether and 30% alcohol mixture. It's very volatile. And then, I mean, I should maybe make a cleaning video. What you do is I don't have the solvent now with me, is you basically take a tissue paper. You place the lens here, and you do not apply it directly on here, but you apply the cleaning solution on the tissue paper, and you pull it over like this, okay? And you keep on doing this, and this is how you clean it. So basically, you try to remove it, anything on here without pressure. Because why without pressure? Because if there is any dust on here, and if you start rubbing it, then you're actually starting to might make scratches on the front lens, okay? So the idea of removing this like this is actually to prevent any solvent from actually flowing in, and also to make sure that there is no pressure. Okay. Yeah. So a few other questions. Okay, I thought we were going to immersion oil. Thank you, Always. I made a cleaning video. I have my own microscope that has a magnification of 2,500 times. I'm 13 old. How old are you? I'm 50. I turned 50 in May. I know I look a little bit younger than I actually am, but I'm actually already 50. Sometimes time passes very quickly. So I'm going to do now the following. I'm going to now actually do the thing here, and I'm going to lower this. And let's have a look at the slide. Yeah, I'm just gonna use this 60 times. Then as a maximum, I'm going to use this now. Just gonna and let's have a look at the dried yeast cells. Okay, see, I cannot go higher anymore. Again, because of the focus lock. Okay, so these are the dried yeast cells. Okay. Okay, so as you see, as when they dry, they actually start to go a little bit into clusters. Yeah. So far nothing new. Okay. Generally, however, the reason so 60 times is the maximum I want to show you now. Okay. However, do notice one thing. Okay. It's a little bit blurry. Okay, it's not quite as number one. And number two, notice that the borders are kind of dark. And this is because it's surrounded by air. Okay. And let me see what if the thickness, there is also no cover glass on here. And usually the lens expects a cover glass for maximum resolution. Okay. So what I'm going to do now is I'm going to heat fix this, okay, and let's see how this then works. I'm going to carefully take it out. Maybe I should actually engage again the focus lock. Okay, so I'm going to switch over again here. And instead of using a Bunsen burner, I'm going to use, this here, a lighter, hoping that I'm not going to, it's not going to crack. Okay, so that's a very, yes, that's better. Okay, no, not hot enough. Ah, I touched it. See, and now there is soot on here. Not a good idea. Okay. Yes, this should be okay. Okay. It is very hot. Yeah. You can also see that the color changed a little bit. It turned a little bit whiter. And now I'm going to wipe this somehow. And I actually did not want to use a... So I'm going to clean off the soot. So that's my mistake. And that's why you should actually use a proper Bunsen burner and not some kind of a candle or a lighter. Yeah, but that's okay. Yeah, let me. Okay, I'm just going to use this here anyway. I'm going to get it cleaned. So the cells should now be baked to the glass, and I do actually see a difference. It's a little bit like when you put an egg on a frying pan, it turns white because of the proteins that denature, and something similar happened here as well. I don't know if you're able to see it, but it is a little bit whiter, the spot. Okay, yeah. So then I'm going to put it back in here into the microscope. Okay, and we see that the cells are still here as before. Okay, so now let's try the oil immersion procedure. As before, I'm going to now rotate the oil immersion objective in place. Notice that there is now no cover glass. Okay. Okay. So I'm going to, the lock is now engaged. I'm going to lower it. And, okay, yes, it's still engaged, so I'm going to lower it. There was already a little bit of oil on here. So let's put a little bit more oil. And of course, you have to be always aware that you do not know how the cells will react with the oil. So yeah, that could of course also be something. Yep. And let me change to the correct setting over here. Yep, and here are the cells. And yeah, the contrast is not so high. But you're going to see again that the structures inside the cell are visible. Okay, but again, two ways in which the cells have been processed. First of all, three ways actually. They have dried, they were heat fixed, and now they are in contact with the oil. And this basically means that they might appear different than when when they're simply in water, and they do look different. Okay. However, this is the only way that you can sometimes use without them being flushed away when you stain them. Okay, but I think honestly, the previous one looked a little bit more contrasty, looked a little bit better. Well, maybe let me close the thing a little bit more here. Yeah. Yeah, so that is basically simply a process of heat fixing, and but honestly, I think the contrast is not quite as good as the other one. So a couple of other comments. Where do you find the specimens? Do you buy them or do you find them in the wildlife around you? Well, let me quickly go through them. Both. Well, those specimens, of course, here that I have here, the ready-made ones I bought, Amazon. And all of the other things that I'm doing, I find around it. And maybe, I don't know if you're new to this channel or not, this is not my main microscopy channel. I have another main microscopy channel called Microbehunter. This one is called Microbehunter Microscopy, but the main one is simply called Microbehunter. And this is where I basically show you how I'm collecting specimens in nature and how I put them, how I prepare them and how I put them under the microscope. So if you're interested in actually going out and finding specimens, also do check my other channel. Okay. Start with house, in the house, like dust, yeast, sugar. Yes, there are plenty of things that you can find at home. Oil immersion microscopy has many pitfalls, breaking the slide, scratching the objective, many steps involved. Yes, and for this reason, I do not recommend oil immersion microscopy for beginners. Okay. Okay, thank you for the advice. Do you mention a viewer of age? You're 50. I'm 78. I just thought you might like to know you have a very wide range of viewers. Yes. One of the things that I like about any hobbies like these is yeah, it's a very unifying hobby across the world and different age groups. Yeah. Don't clean the lenses with acetone. Absolutely correct, because acetone might actually dissolve some of the lens kits, the glue. Yeah. Pond water is also very interesting. Yes, I also have done this. Is dark field possible with oil? And I will tell you probably not. And the following reason. First of all, dark field microscopy can be done, for those of you who don't know this, by putting a small dark field filter, also a homemade one, into the filter holder. Dark field microscopy works for magnifications, let's say maximum up to, if it's good, maybe around with a 40 times objective. Okay, 40 times objective. This is already stretching it. It's becoming already very dark. And then if you want to go up yet higher, then then it's going to be simply too dark. Okay, and the other thing is that dark field microscopy depends on a refractive difference between the specimen, and if the refractive difference is not high enough, then it's going to simply look transparent. Yeah, so I would say that dark field possible with oil. Correct me if I'm wrong. There are specific so-called dark field condensers which do not work with a filter, but they have a concave mirror system which are able to concentrate more light, and maybe, I don't know, it might work there. But I would say with the homemade solution, I'm already at the limit. I'm stretching it already with a 40 times. Yeah. Yeah, never knew that yeast had a middle. I think when you say middle is that there is stuff inside a yeast cell. I guess this is what you mean. Basically, yeasts are so-called eukaryotes. Actually, let me go back here to show you. Yeah, I mean, this is actually, honestly, I don't like this specimen here so much. Let me go back to the other one, okay? Because the one with where I had it in water. Just a second. Okay, let me lower this again. Let me put in the other one. I'm going to put it in simply here next to it. My slide holder is able to accept multiple slides here. And let's go up again, hoping that there's still enough oil in here. Yes. Yeah. Actually, I think, look, the shape is different here. The yeast cells, they don't like the oil so much, right? Okay, if you look carefully into the yeast cells in here, you might actually see some dots and so on. Yeah, so these are cell organelles. Yeast cells are eukaryotes. This means they have a nucleus. So they have a nucleus, they have mitochondria and so on, barely visible here now with a light microscope. But if you have an electron microscope, I don't have one, then of course you're able to see that. Yeah? Bacteria, however, they look homogeneous, uniform in the inside, because they do not have any cell organelles. Yeah? So basically, a yeast cell has a cell membrane around it, and the individual cell organelles in the middle, they also have a membrane around it. And that's why they're different parts. Yeah, but in a bacterium, the bacteria, not only are they much smaller, but they're uniform, and therefore you're not able to see anything inside a bacterium. Okay. What should be done if fungus appears on the objective lens? So it basically means that you have a fungus growing on the objective and in the objective. This can happen. that's very unfortunate, and this can happen especially if your microscope is in a very humid environment, in the tropics, for example. And this is a known problem, and the problem is so big of having fungus growing on the optical surfaces that actually some companies make objectives that are coated with an antifungal chemical, to prevent the growth of fungi. I've had fungi growing on very old objectives of old cameras even. So what can you do? Well, honestly, not much. If the objective is a very expensive one, then you have to send it in and get it cleaned. It will be disassembled. Otherwise, if you've got relatively low cost objectives like these ones here, buy yourself a set of new objectives. Honestly, it's not worth trying to fix it. Those objectives can be bought. Because some companies in Europe and in the United States, they don't sell those objectives, but I buy them directly from AliExpress, directly from China. You get them quite cheaply. It takes a couple of weeks for them to arrive, but they basically, the companies that are making those directly sell the objectives then over AliExpress. So that's actually something I would recommend. My client was heat fixing and staining. They also use mineral oil and do not clean very well after use. I recommend and use a product called Roar. Okay, I don't know that. That's an interesting one. Well, in any case, if you clean your objective lenses, generally the companies, at least the higher end companies, they have specific recommendations on how to clean them. For the low cost objectives, I would say just use pure alcohol. That is possible, but only clean them if it is absolutely necessary. But I do have to tell you what I once did. It's even worse. I did not get immersion oil on my 40 times objective. I got some mounting medium. UKIT mounting medium is a resin-based mounting medium on my 40 times objective. How did I manage to do that? And it was a good objective from Olympus. How did I manage to do this? Stupidity. Because I was not patient enough, I made a permanent mount, and I had some of the mounting medium spill out from the side of the cover glass. Okay, and then if this were the slide here, I had some mounting medium spill out from the side of the cover glass, and I did not clean it off. I was not patient enough to wait for it to dry, and I rotated directly the objective into the mounting medium. And this is a very fast drying mounting medium. I panicked, but I got it cleaned off completely using alcohol, alcohol ether solution. So this is of course a problem. My oil immersion lens is showing permanently black spots. I recommend the following. If you want to check any objective that you for how clean it is, take it out and look at it from the backside. Okay? Look at it from the backside, hold it against some light or against a bright background, or maybe use some magnifying glass or an eyepiece to magnify it. But actually, you can see it quite well if the objective is dirty or not. You cannot see it sometimes from the front. Okay, difficult, but usually you can see it quite well from the back. Okay, you can try it out. It is actually works quite well. Okay, so. So this is what time is it now? Okay, it's already 1 hour. So this was simply a short intro into oil immersion. In order to summarize this, especially for those of you who join in maybe later a little bit, and there's also a comment I want to make concerning the magnification later on, is that be careful that you do not contaminate oil immersion only on the oil objective, so it has the word oil printed on it. Okay, I've received questions of some beginners some time ago who wanted to improve the quality of the image, and they tried to use immersion oil on all of them. That's dangerous. Okay, don't do that. Once you've got immersion oil on here, do not switch back to the lower magnification, because otherwise you're going to contaminate those as well. Okay, and And be careful that you don't crash the slide, obviously into the objective. And to remove the bubbles, what you can do is you can go back and forth a little bit like this. Yeah. So, but I would like to now show you how I clean the whole thing. Okay. What I usually do, you know what I can do? It's actually quite nice. Look, we're just a second stage cam. Can I change the size of this? Ah, that's nice. Okay, I think that's better. Okay. So I'm going to clean this. So I'm going to lower this again. I'm going to turn off the light. It's kind of blinding a little bit. Okay. I remove this, both of them, because I do not want to have any oil anywhere. And then what I do is I take a lens paper, and all I do is very lightly, okay, you see that's all of the oil, right? And then of course you have to be careful that you still don't contaminate the other lenses. Just want to carefully wipe off, yeah, maybe go like this a little bit. Yeah. The thing is the following, the front lens is concave. Okay, I just want to tell you another story what the guy from my sales representative, I always call him one of a question, and he's kind of also a little bit a support and technical advice. Yeah, see, now there's nothing. Yeah, there's nothing on. Yeah, that's the oil. Okay, and then I throw it away because I don't want this. Yeah, and what the sales rep said is the following: because I was kind of worried, at least with those objectives that I have here, is that the front objective is not completely flat, but it's actually concave. It actually goes inwards. So basically what happens is if you do crash the objective into the slide, it's not very likely to damage the front lens. Don't move it horizontally, but it's going to first, I'll use this here as an analogy, okay? It's an exaggerated analogy. Yeah, basically if you crash it in, then the lens is further inwards, and therefore it's first going to crash here on the side, okay? And because the front lens is concave, it goes inwards, it's sometimes difficult to clean it. Okay, because the dirt is in there, and if you just wipe over it superficially, you're not going to catch the dirt that's inside. Okay, and so my sales representative told me is don't be afraid. Take some some cleaning paper and take your fingernail and actually starts. If there's too much dirt and oil in there, start with your fingernail, start scratching it out a little bit. And he says, don't be afraid. The lenses can actually withstand more than you might think. Okay, but he said many people are afraid of doing that because they're afraid of damaging the lens. But he says that's okay. The lenses are kind of designed. Of course, you don't want to use any sharp object, but if you use I don't know some lens tissue paper, okay, and you actually go in, and he says you actually sometimes have to really go in a little bit and to get the dirt out. Yeah. So just to show you a little bit that we have to be careful, but there's no point in exaggerating here. Okay. Yeah, some off-topic questions that I also would like to talk about. Thanks, Oliver. Halogen or LED light source is better? That's if you get me started on this. Let's put it this way. These These days, if you get yourself a good microscope, with modern LEDs, then it can be that LEDs has certain advantages over halogen. However, there are some cases where halogen has an advantage. I will simply outline, simply because I know it's maybe a totally different, the topic of a different video, but still I want to answer those questions. Halogen has the following disadvantages. It has, first of all, it creates a lot of heat. Okay, so that means the sample evaporates faster. The second disadvantage is that if you do photography, if you change the light intensity, then you have essentially also a change in color. If you turn down the light intensity, the color becomes more red. If you turn up the light intensity, the color becomes more blue. So you have to work with white balance when you take pictures. Number 3, what I read somewhere is that because halogen has a more natural and a wider spectrum, it is more people who have been working in a hospital with certain staining techniques, it kind of reproduces the stains apparently better, the color. Halogen produces more natural colors because the spectrum is wider. So this is, you see, it has advantages and disadvantages. LEDs, however, I would say it depends a lot on which type of LED you have. So for example, my microscope, what they were advertising it has LEDs, and they said is even though it has LEDs, it's a special one which looks like natural light, like halogen. Yeah. So in other words, the color reproduction of stains is more authentic, or as authentic. But this was a specific thing that they were kind of specifically advertising. Yeah. So I would say it's a question of taste to a certain extent. Yeah. There are still halogen, lots of halogen microscopes around. There are more and more LED-like microscopes around. I would say if the halogen is brighter than LED, then halogen is better because, I don't know. Yeah, I would say both have advantages and disadvantages. Yeah, and the old mirror, yeah, the mirror, yeah, is if you use a mirror, then you can use a flashlight. Okay, then you can of course also adjust the color of the light. Yeah? So I think I'm just going to leave it at that for right now. I've got to make this again a little bit smaller, or can I actually just a second, maybe I can. Yeah, that was the original size. Okay, yeah, I think I'm just going to leave it at that. I hope that it was informative. Yeah, no, there's one comment I wanted to really talk about. Yeah, here. Daniel commented, I have my own microscope that has a magnification of 2,500 times. I simply have to say this as well. Yeah, you get 2,500 times by using 100 times oil immersion objective, okay, and a 25 times eyepiece. Yeah, and you multiply those two 25 times eyepiece times 100 times gives you 2,500 times. My suggestion is just use the 10 times eyepiece. 2,500 times is already very, very much. You're going to lose a lot of brightness. The image is going to be darker. Focusing is going to be more difficult. And I would say that yeah, by going up with the magnification, you do not automatically always see more. Okay, and my suggestion is to stay with the 10 times eyepiece. Okay, so but yeah, otherwise I think I'm just going to leave it as it is right now. I hope it was again informative for you. I wish you all the best. Hope to see you again next week. I still have to think of a topic. Maybe I'm going to do a general question and answer session again. Could also be a possibility. I don't know yet. If you have any suggestions, of course, please write them. Yeah, I wish you all the best. Yeah, see you around next time. Happy microbe hunting as always. And if you're new to this channel, don't forget to visit my main channel called Microbehunter, where I post also regular videos. Okay, all the best. Bye bye. Yeah, see you around next time. Okay. Can we see your microscope? Oh, okay. I think I'm going to maybe make a separate session where I introduce or show you all my different microscopes that I have. Okay. Bye bye everyone. See you around. See you next week.